Can you see my screen?
Yes, ma'am.
So have we discussed this question?
Yes, ma'am.
Where we were just making the embankment out of the soil, which we were taking it out from the well. Have we finished this?
Yes, ma'am.
Okay, let's move ahead. Okay. Oh yeah, we were discussing this, and I think volume of the cylindrical well is equals to volume of embankment, and we have seen that how to find the volume of embankment. Okay, yeah, we have finished that. Let me take few more questions from here. The question says, a gulab jamun container contains sugar syrup up to about 30% of its volume. Find approximately how much syrup would be found in 45 gulab jamuns. Each shaped like a cylinder with two hemispherical ends with length 5 centimeter and diameter 2.8 centimeter. Let's do it. So here we are having gulab jamun. Contains sugar syrup up to about 30% of its volume. Find approximately how much syrup would be found in 45 gulab jamun. What's the shape of the gulab jamun? It's shaped like a cylinder with two hemispherical ends. It's shaped like this. This is the shape, okay, where you can see cylinder is there in the middle and two hemisphere at the ends. Okay, do we know all the information related to this shape? So, is shaped like a cylinder with two hemispherical ends with length 5 centimeter and diameter 2.8. Okay, the total length is given as 5 centimeter and diameter is given as 2.8 centimeter. What to do over here? We have to find we have to find approximately find approximately how much syrup would be found in 45 gulab jamuns. So what to do over here? Anyone?
Ma'am, volume of cylinder plus 2 into volume of hemisphere.
Volume of cylinder plus 2 into volume of hemisphere. Yeah, that will give the total volume, right?
Yes, ma'am.
So volume of cylinder we will be finding. What's the formula for volume of cylindrical shape?
Pi r square h.
Yeah, pi r square h. Do we know, like, do we have all the information in hand, that is radius and height?
No,
For the radius, we can divide the diameter by 2.
Okay, perfect. Radius we
And,
got.
and then for the height, we can minus 1.4 from 5 to
So,
get the height of the cylinder.
so 5 minus 1.4 will give the height of the cylinder.
no, ma'am. 5 minus 2.8.
Yeah, exactly.
Oh,
5
right.
minus 2.8 because we are having two hemispheres. So here we are having one radius and here we are having one radius and we just need to find the height of this cylinder. So from the right hand side, left hand side, we have to subtract the radiuses. So obviously it will be 5 minus 2.8 and that will give the height of the cylinder. Once we'll be finding the total volume, now we just have to find the volume of 45 gulab jamuns, right?
Yes.
Yeah. After that, one more step will be there because it says that the gulab jamun contains sugar syrup up to about 30% of its volume. So 30% in that total volume, we will be having sugar syrup and we have to find the volume of sugar syrup only. How much sugar syrup? As you can see, it's written. Find approximately how much sugar syrup. So obviously, whatever volume we will find, total volume. First, we will find, as you said, the volume of the cylinder and volume of the hemisphere all added together will give the total volume. Now, total volume we will be finding of 45 gulab jamun and that's 30% at last we need to find because we need to find the quantity of sugar syrup in this gulab jamuns, right? Okay, let's move ahead. Water in canal 6 meter wide and 1.5 meter deep is flowing with a speed of 10 km/h. How much area will it irrigate in 30 minutes if 8 centimeter of standing water is needed? Okay, this is the question. Let's see what exactly the question says over here. So water in a canal, so which is 6 meter wide, 1.5 meter deep. So the canal is having the shape of cuboid. This is the shape of canal where 6 meter wide, that means width of this canal is 6 meter. 1.5 meter deep means height of this canal is 1.5 meter. Flowing with a speed of 10 kilometer per hour. So water is flowing over here with a speed of 10 kilometer per hour. Okay, so we know width of the cuboid, that is 6 meter. We know height of the cuboid, that is 1.5 meter. Now water is flowing through this canal. How much area will it irrigate in 30 minutes if 8 centimeter of standing water is needed? So what to do over here? Any idea? Here its speed of flowing water is given. That is 10 kilometer per hour. Anyone? Okay, let's discuss it. So here speed of the flowing water is given as 10 kilometer. 10 kilometer water is flowing in 1 hour. Okay, let's see in 1 minute what will be the, like how much water will flow. So in 1 hour, how much water? It's covering the length 10 kilometer. That means in 60 minutes, the water is flowing 10 kilometer. So in 1 minute, water will flow. Okay. So here everything is in meter. Okay. This is all. This is in centimeter. So from the very beginning, let's keep everything in centimeter only. Okay. So that afterwards doing the calculation will be easier. And as you already know, we need to keep all the units same. So here we can write 6 meter as a 600 centimeter. This one we can write as a 1.5 meter as a 1.5 times 10 times 100. So 150 centimeter. Is it clear to everyone? Is it clear?
Yes, ma'am.
We are just converting the unit. Now kilometer to meter. 1 kilometer is equals to how many meter? How to convert kilometer to centimeter directly?
1 kilometer to meter is 1000 meter. So,
And meter to
centimeter.
centimeter?
Meter to centimeter is 100.
So we can directly multiply. And if you know this table, if you have learned this table somewhere, that is kilo, hecto, deca, meter, deci, centi, milli. This table will also help you that whenever we come downside, it's multiplication. When we go upside, it's division. And for one step, it's 10. One step consists of 10. Okay, so we have to come from kilo to centi. So 1 step, 2 step, 3 step, 4 step, 5 step. And since we are coming down, multiplication. So 10 times 1, 2, 3, 4, 5. 1 with 5 zeros. All right. So we will be getting 1 with 6 zeros. That much centimeter we will be having. All right. In 1 minute, we have to divide it by 60. So let's divide it. per minute. Is it okay? Or you can also keep everything in, just a moment. Just give me a second, no? Let me share it again. Yeah. Or you can also keep all the unit in meter only. Okay, it's completely up to you. Here, any unit is not given that we have to keep the unit this one only. So you can also keep all the unit in meter, centimeter, whatever is given in centimeter that you can convert in meter. Kilometer you can keep in meter. So either keep everything in meter, 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 or if you want, keep everything in centimeter. Okay. So this is what we will be getting over here. This much centimeter, or you can go ahead with the meter also. Now in 1 minute it will be 1 2 3 4 5 6 divided by 60. That much centimeter per minute we will be having. That much water is flowing, that much centimeter water is flowing in 1 minute. Okay. Now if we have to find the volume of canal in 1 minute, it will be length that much centimeter in 1 minute. That means this is the length. Okay, this is the length which is getting covered, which is through that much water is flowing in 1 minute. So this is the length. Okay, so 1 2 3 4 5 6 divided by 60, this is the length in 1 minute, into width which is already given 600, into height which is already given as 1.5, we have converted it 150. This much is the volume in 1 minute. Are you getting? This is the volume in 1 minute. What is the question? What the question says? How much area will it irrigate in 30 minutes? In 30 minutes we have to find. That means volume in 30 minutes will be this all multiplied with 30. Are you getting?
Yes, ma'am.
So everything divided by 60 into 600 into 150. This is the volume. This was the volume in 1 minute. Now in 30 minutes into 30 will be the volume. We have to find how much area will be irrigated in 30 minutes if 8 centimeter of standing water is needed. Now if you know that volume formula came from area times height. From here only volume formula came. If you wanna check, you can check it. That volume of the cuboid is length into breadth into height. Area of the rectangle into height. Volume of the cube is a cube. That means we can write it as a square into a. Area of the square into height. Volume of the cylinder is pi r square h. Pi r square h. So that means area of the circle times h. Basically, the volume formula came from area into height only. Okay, in three-dimensional shape, we are having height also. So what we are thinking, earlier we were having 2D shapes. That means plane shape, the flat shape, where only area used to be covered. So now volume, when we are thinking about the volume, when we are thinking about the capacity of any 3D shape or solid, we are thinking that area is getting covered. But apart from that, height is, it is also having some space for the height, right? So from there only it came out that volume, okay. So the concept of volume came from area covered times height. All right. So this formula, from here only each and every volume formula came out. And this formula only we are going to apply now. That volume is area into height, right? Let's write it. This is the volume in 30 minutes. Now it says how much area is getting covered if 8 centimeter of standing water is needed. We know volume is area into height. How much standing water is needed? 8 centimeter of standing water is needed. How much area, like what is the portion which will be irrigated if 8 centimeter of standing water, the height of the water will be 8 centimeter. What volume we need to irrigate? The volume which we have already found. This volume we will be writing over here. That is 1, 2, 3, 4, 5, 6 divided by 60 into 600 into 150 into 30 is equals to this one. And from here we will be getting the area which will be irrigated in 30 minutes when 8 centimeter of water, like standing water, is needed. Let's summarize the whole concept. Let's see what exactly the question says. Water in a canal. Canal is having the shape of cuboid. What is the measurement of the cuboid? Length, breadth, height. The width is given, height is given. We are searching the length, but the length is not given. It says the speed, the water is flowing at the speed of 10 kilometer per hour. That means 10 kilometer in 1 hour. With that speed, the water is flowing. Okay. How much area will it irrigate in 30 minutes? That we have to find. So what we are doing, volume we are finding of the canal, that is length into breadth into height. All right. We are finding volume and the speed which is given, that is 10 kilometer in 1 hour. We are converting it in minute. What will be the volume in 1 minute? What will be the volume of the canal in 1 minute by taking 10 kilometer as a length? Okay. So we got the volume of the canal in 1 minute, but the question says volume in 30 minutes. So we have found volume in 30 minutes by multiplying it with 30. That volume we are keeping in hand. Now it says that how much area will it irrigate? That much water which is flowing at the speed of 10 kilometer per hour, that much volume of water will irrigate. How much area will it irrigate? That much volume which was flowing, it will irrigate how much area? If 8 centimeter of standing water has to be there. We know volume formula came from area into height. We are just breaking our volume formula into in area times height. 8 centimeter of standing water is needed, so height we are taking as a 8 centimeter, area we are writing as it is, and then we are getting the area which will be irrigated. Is it clear to everyone? Is it
Yes,
clear?
ma'am.
Okay, let's move ahead. A farmer connects a pipe of internal diameter 20 centimeter from a canal into a cylindrical tank in a field which is 10 meter in diameter and 2 meter deep. If water flows through the pipe at the rate of 3 kilometer per hour, in how much time will the tank just a minute now. So in how much time will the tank be filled? Let's see what exactly the question says. So here the question says a farmer connects a pipe of internal diameter 20 centimeter from a canal into a cylindrical tank. So farmer is connecting a pipe like this into a cylindrical tank. This is what the question says. Farmer is connecting a pipe of internal diameter this much. The pipe is connected from the canal into the cylindrical tank in her field, which is 10 meter in diameter and 2 meter deep. This is the measurement of the pipe, that 10 meter is the diameter and 2 meter. Okay, let me read it properly. A farmer is connecting a pipe of internal diameter 20 centimeter. Okay, pipe is having internal diameter of 20 centimeter from a canal into a cylindrical tank. Okay, the cylindrical tank is having 10 meter diameter and 2 meter deep. Let's write it. The tank is having diameter 10 meter and deep means height 2 meter. What else is given? If water flows through the pipe at the rate of 3 kilometer per hour, in how much time will the tank be filled? So water is flowing at the rate of 3 kilometer per hour. How much time? In how much time the cylindrical tank will get filled? Anyone from here? How to do it? What is the total time so that the cylindrical tank, this is cylindrical tank, this will be filled completely? Anyone? Here we don't have to do anything. We will just be saying that volume of this one, the tank will be full when the volume of this one and this one will be same, right? Yes or no? Right? When the volume of both the cylinder will be same, then the tank will be full, right? So volume of this pipe, can you see the screen?
Yes, sir.
So volume of this pipe will be, it's a cylinder, pi r square h. Volume of this one will be, it's also a cylinder, pi r square h. Okay. So what is the diameter? Diameter is 20 centimeters. So radius will be 10 centimeter over here. So let's substitute it. So pi 10 square. Okay, here also centimeter, meter is there. So be careful. It will be 10 by 100 square into Height we don't know. Okay, still we don't know the height. We are just assuming the case that when both the volume will be same, then our tanks, the cylindrical tank will be full. That's what we are assuming at first. So we are saying the pipe's volume, that is 10 by 100 square. Height of this pipe we don't know, is equals to volume of this cylindrical tank, that is pi r square. R is 5 over here, h is 2. This is what we are getting the first case by assuming that when both the volume will be same, then this cylindrical tank will be full. From here we will be getting the height of this pipe. Okay, so let's see what will be the height of the pipe. This two will get cancelled out. Let's do it quickly. Here 10 times 10 is there, here 100 times 100 is there. Forget about this two. This and this. So we got 1 by 100 over here, which will go to other side. So we will be having 25, 2 times 50, and 100 will go to other side. That means 5000 meter, right? Now one information is given over here that 3 kilometer per hour, the water which is flowing through this pipe. Here it's written that if water flows through the pipe at the rate of 3 kilometer per hour, in the pipe the water is flowing at the rate of 3 kilometer in 1 hour. Okay, so how much water we need? We need 5000, like this much water we need when the height is 5000 meter, and it says it is flowing at the rate of 3 kilometer in 1 hour. It is flowing at the rate of in 1 hour 3 kilometer, or you can write it the other way, that water is flowing 3 kilometer in 1 hour. That means 3000 meter in 1 hour. Okay, we have to find it for 5000 meter. So 1 meter, it will be 1 by 3000 hour, and for 5000 meter, it will be 5000 by 3000. That much hour will be needed. Are you getting it? Anyone having any confusion over here? This is
No,
in
ma'am.
hour. If you want to convert it in minute or second, you can multiply with 60. So let's multiply with 60. 5 by 3 hour. This much total time will be needed when both the volume will be same, and that time only our cylindrical tank will be filled. Okay, when the both the volume has to be same, then only the cylindrical tank will be filled. That much we have to understand. Accordingly, we have got the height. If height will be this much, okay, or we can say the distance will be this much. Why we are saying height as a distance? Because when you will place the cylinder like this, earlier we were saying this as a height, now this became distance. Okay, this much distance the water is covering in 1 hour, or this much height the water is covering in 1 hour. It's the same thing, don't get confused. So when the distance covered by the water will be 5000 meter, then only the cylindrical tank will get totally filled. Okay, so one information is given for that, that is 3 kilometer water. 3 kilometer water is flowing at the rate of 3 kilometer in 1 hour. We have to find it for 5000 meter, because that much total distance the water need to go in. How much time water will just flow 5000 meter? That's what we need to find it. Okay, So 3 kilometer in 1 hour, then 5,000 meter in what time? That's what we are finding it. So we got 5 by 3 over here, that much hour. If you want to convert it in seconds or minutes, per minute you can multiply it with 60. So 3 2 times 60. So we can say 100 minute. In 100 minute, the tank will be totally filled. Getting it? Any doubt over here? Just
No,
lead.
ma'am.
Yeah, everyone, it's clear, right?
Yes, ma'am.
Yes, ma'am.
Now the last question related to frustum of the cone. Okay, let's do it. All the important questions from this chapter we have already discussed. Okay, few extra questions also we have discussed from the previous year. Those were also very important, and from the chapter itself today I've searched few questions were there which you need to do, which you need to practice. So these were those questions, and apart from this, very basic few questions are there. Obviously you need to practice those questions also. So let's take the last question, which is from frustum of the cone, and let's finish this topic. Okay, let me draw the figure itself. Okay, I am explaining through the figure only because the statement is quite big. So we are having a bucket like this. Let me read the question. It says that an open metal bucket is in shape of frustum. This bucket is in shape of frustum of a cone. Okay, mounted on a hollow cylindrical base. I have colored the hollow cylindrical base for to avoid confusion. Okay, so a frustum of cone is placed on a hollow cylindrical shape. Okay, a hollow cylindrical base. The diameter of two circular end of the bucket are 45 centimeter and 25 centimeter. So two circular base, as you can see, this frustum is having this circular base and this circular base. This diameter is 45 centimeter and this diameter is 25 centimeter. What else is given? The total vertical height of the bucket is 40 centimeter. The total vertical height is given as 40 centimeter. And that of cylindrical base is 6 centimeter. Cylindrical base height separately is also given. That is 6 centimeter. Let me write that. This much is 6 centimeter. Find the area of the metallic sheet used to make the bucket. Let me write this statement. Find the area of metallic sheet used to make the bucket. Find the area of metallic sheet used to make the bucket. Also find the volume of water the bucket can hold. Yeah. How to find the first thing, that is find the area of the metallic sheet used to make the bucket. Anyone? How much area of the metallic sheet will be used to make this bucket? You can see the bucket shape. Clearly, I have plotted the figure over it. Anyone?
For the area, can we say that for the area we have to like add the two of the shapes, right? The CSA.
Yeah, the frustum and the bottom one cylinder, right? Right?
Oh yeah.
That's it. Anything? Are we missing anything? Yes, whatever you said, that's perfectly fine. But is there anything which needs to be considered over here? This is the bottom. And as you can understand, the bottom must be like this is just the base which will help to stand the, just keep the bucket on the ground or something. So this shape is obviously a cylindrical shape, and once we will be finding the of area of this one, we also have to take the consideration of this area, the circular base area, because there will be a solid plate, right? A circular plate. Getting it? Are you getting?
Yes, ma'am.
And the bottom one is cylindrical shape, just to give it a hold, just to keep it on the ground. Like in your most of the table or something, you have seen there is a something as a base, right? To just keep it firmly on the ground, right? Have you seen? Let me show you. Let me share it. Can you see it?
Yes, ma'am.
Can you see my mouse?
Yes, ma'am.
This type of structure is there in the bucket. Okay, just a cylindrical shape at the bottom, which will not hold water. It is just for fixing the bucket. The way here the table is having the bottom part just to fix it firmly on the ground. Similarly, the bucket is having the cylindrical, hollow cylindrical shape at the bottom. But that cylinder will not occupy. Like if you will pour the water in the bucket, only the frustum of the cone will occupy, like it will contain water. But the cylinder is just to keep it firmly on the ground, just like this one. Okay, so let's get back to our figure. Now you will be able to visualize that in our figure we are having a bucket where the bottom will be there, right? The bottom will, a frustum of the cone will be there. There is a formula for that, but that formula is applicable when both the ends are empty. Okay, the surface area formula which we are having for frustum of a cone, there the upper end, downward end, both are just hollow. That formula we are having. If we have to find the area of the metallic sheet, then you can understand the curved surface area and the bottom circular part and the hollow cylindrical part area. Getting it? Is it clear now?
Yes, ma'am.
So let's do it. So this cylinder will be having the curved surface area as it is a hollow cylinder, that is 2 pi RH. Before that we are having a circular bottom. A circular plate must be there so that the bucket can hold water. And before that we will take the formula for surface area of this frustum of a cone. Now do we have all the information in hand? Just a second. So the formula for surface area of a frustum of a cone is pi L. Pi RL is for cone, and for frustum of a cone we are having pi L R1 plus R2, right? R1, R2 we already have. Slant height. Do we have slant height? How to find the slant height over here?
R
Anyone?
square plus H square.
Yeah, that is for R square plus H square, the slant height formula, under root R square plus H square, that is for cone. Here we are having frustum of a cone. The same formula we are having, but here we are having two radiuses, as you can see. How we get the frustum of a cone? When we are having a conical structure like this, and then you will be cutting it from here, maybe with a plane, with a flat plane surface. When you will be cutting it from here, you will end up having this type of a structure. This type of a structure you will able to see. Upper one gone. Okay, the upper part we are just removing it, and we are talking about this part. So this part is called the frustum of a cone. Where we see this type of shape, when you will see a cap, when you will see a bucket, you will see both the diameter, both the radiuses are different. The lower end, upper end, there is one bigger one, and the bottom one is a smaller one. It's not like the it's not like the cylinder. It's not uniform throughout. So there will be two radiuses over here. For such figure, we are having formulas. Let me write the formula. Volume of frustum of a cone 1 by 3 pi. For cone, it was 1 by 3 pi r square h. Here also we are having the same formula, but since we are having two radiuses, due to that there is a slight change in formula, that is r1 square plus r2 square plus r1 times r2. This is the formula for volume of frustum of a cone. For cone it was 1 by 3 pi r square h. For frustum of a cone, two different radiuses are there, as you can see in the figure itself. This one are completely different. So for this one we are having this formula. Now the curved surface area formula is pi r l over there. Here the curved surface area formula is pi r, r1 r2 is there, so that r1 r2 we have to take in consideration. So pi l will be there times r1 plus r2 will be there. What is the total surface area? Here we need to add. The total surface area will be the curved surface area, that is pi l r1 plus r2 plus upper part area pi r1 square plus lower part area pi r2 square. Okay. Now slant height, how we will be finding? There we used to find the slant height. L is equals to under root h square plus r square. Here also it's almost same like that, but here we are having two radiuses, so it will be the bigger radius minus one of the, like r1 minus r2 square. Okay, since we are doing the square, so bigger radius minus smaller radius square, or smaller minus bigger square, it will come out as a positive number only. So this is the formula for this shape. The deduction of this formula is not required for uh, in at your level. You just need to know this formula, and there will be very simple questions from this, just will be based on the formula itself. Okay, so let's wrap it up. Here we are having what we have to find: the slant height L we have to find, and now you can see the formula for L is h square plus r1 minus r2 square. Easily you will be able to find. The height is given, the total height is given as a 40, but the cylinder's height is also given. So let's exclude the cylinder's height. That means 40 minus 6 you will be doing, and then you will get the height of only frustum of a cone. Once you will get the height of frustum of a cone, then easily you can find the slant height since both the radius is given. How much metal will be used? That means the already we have discussed the frustum of a cone, the curved surface area, then the circular bottom area, and then the hollow cylinder's curved surface area. You will add all of them and you will get the area of the metallic sheet which will be used. Now the next part is asking find the volume of the water in the bucket. So if you are thinking about the volume, forget about the cylinder and all. We are just focusing on this frustum of a cone because cylinder will not occupy anything. Okay, it is just for the showpiece. It is just to keep the bucket on the ground firmly. Okay, so